perfectly.
I couldn't get it to work.
For real?
Evan completely broke it.
I didn't understand anything.
I hate all of you. All right.
I don't hate me.
Except for Ellie. Okay, so let's do this. Let's take a look at, we did 6, we did 5 yesterday, correct? And we said we'd leave off and then do 4. Oh no.
I should just go
Mine's already 10 minutes, and then I cut it down to 5.
I think it goes the other way.
But then I like fast forward. Yeah, that's fine.
That
So
way?
is it bad?
I think so.
Yeah.
A little bit of ASMR in mine.
It's like the
It
con.
goes over your nose.
It's like
What is it? You breathing?
Stretch it out.
Don't you like
I know, I'm just like banging
like
my
that thing?
spatula.
That's what I do.
I don't think
Why am I standing? I don't know.
Got it.
Okay, just.
I had to wear one of those. There you go. I won't get his hand.
Like all this.
All right, let's do it.
We didn't share take mine.
It's raining.
So we did number 5 yesterday, and we said we'd do number 4 today. Because we have some people returning, I would like to start maybe with a little bit easier one. Let's take a look at number 7. Let's try that.
What's 5 on this?
I told you you don't necessarily need it. You can use it to try it again on your own if you want to study for the quiz next week. That's something you can use it for, or you can just recycle it like a heartless person like Erica did. All right.
Oh, 7.
7. AC and BC are congruent.
Poor Erica.
That's that. We also know CD and AB are perpendicular. So here's CD, here's AB. That there is a 90-degree angle. Guys, either get better at basketball or just stop trying. FE and AC, Morrison's finest.
We get it.
You are literally on the basketball team. All right.
We get it, Max.
So we've got this.
You're literally.
Like, I mean, you don't
You're really
have to
good at
stop
trash
throwing it.
can
I just want you to stop sucking. All right.
Just remember.
Trash
Do you have a rubber
can
band?
basketball.
No, I do not. I'm sorry. Do you need to tie back your hair? Is that what's happening here? Because I wouldn't recommend rubber band. It's a bad idea.
No, it's like everything is falling apart and I need a rubber band to hold it together.
My game's based off
Well, this
Sure.
one.
Figure it out.
Nice catch.
You're a bandwagon.
In here.
Yeah, I don't care. All right, so here we go. That's why we do it live. All right, so
I'm gonna sit with
we're going to prove that AE and BC, when multiplied together, AE is this right here.
Just not Jessica gave me a haircut. So.
Wonderful. And then BC is this bit right here. We're going to prove that these guys, when multiplied together, are going to be the same as when AF and BD are multiplied together. Now, what we really mean with this, right, we can move this around and do division. I can say that AE divided by AF is going to relate the same way as BC, or BD does to BC. Something like that, right? We're going to get something like that, and then we're going to move stuff around to make it multiplication, right? That's going to be the idea. Something like that. What's on top and what's on bottom might change, but that's the basic idea. Now we know congruent triangles have all the same parts, meaning that angles are going to match up and sides are going to match up. So for those of you that weren't here, congruent triangles would be something like this. 3, 4, 5, 3, 4, 5. And we know by side-side-side congruency, these triangles are the same. Then by CCP, we know that those angles will be the same, right? The corresponding angles. And those are, in fact, congruent triangles, right? They're the exact same thing. This is great. This is fun. This is fantastic. But there's not a whole bunch you can do with congruent triangles, right? It's kind of boring. We see two triangles. They look like they're going to be the same. Oh, look, I proved it. Great. Wonderful. Excellent. That's good. What we're doing now is we're talking about similar triangles. So, for instance, these would be similar triangles. Those are similar. They're not the same because they have different side lengths, right? But they are related in the same way. Notice that 3 relates to 6, meaning that it's half, right? The same way 4 relates to 8, half. 5 relates to 10, half. 3 over 6 is the same thing as 4 over 8, is the same thing as 5 over 10, and it all reduces to 1 over 2. Now, could we have gone the other direction and said 6 relates to 3, double, the same way as 8 relates to 4, double, the same way 10 relates to 10, or 10 relates to 5, double? Yes, we could. We'd flip everything and we get 2 over 1, right? So it depends on which way you're going, from small to big or big to small. But in general, as long as you're consistent going from one triangle to the other, or one triangle to the other, then you'll have the same ratio. That's what happens when you have similar triangles. And we know similar triangles don't have the same sides, right? They have proportional sides. That's what this means, right? They all relate the same way, by a half, or double if you're going the other way. But we do know that similar triangles have congruent angles. So similar triangles have proportional sides. They all relate by something, right? And they have congruent angles. We call this similarity, and we use just the squiggle, the tilde, instead of the equal sign with the tilde over it, okay? That means they're similar. And similar triangles are far more interesting because not always is it easy to tell what triangles are similar, right? And then you can prove interesting things about them. I feel like congruency is kind of boring because it's like they look similar or they look the same. Oh, guess what they are, right? Similar triangles, a lot more interesting stuff going on. So what we're going to prove is these triangles similar. Now, Ellie doesn't know this because Ellie wasn't here, although I'm sure she watched the live stream. Like and subscribe.
For sure.
To prove things similar, we have fewer things than we do for congruency, but they cover more ground. So for instance, we've got 2 angles is enough to prove something similar. Because remember, similar triangles have all the same angles. So Ellie, if I know that these 2 angles are the same as those 2 angles, right, I know the third angles have to match, right? Because what's left over will be the same from 180 degrees, right? So really it's triple angle, but since if we know 2, we get the third from 3, we just say, look, if you've got 2, it's good enough, right? Notice that 2 angles, right? Angle, angle, side is something we had for congruency, right? Well, that's 2 angles, but just overachieving, right? So angle, angle, side is covered by angle, angle. Same thing with angle, side, angle, right? So those are covered all by just having 2 angles. A lot easier to prove triangles are similar than you might think. We also have side, 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 but I have to put the tilde after because remember that's side, side, side similarity versus side, side, side congruency. These triangles have side, side, side congruency, right? My side, 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 I know the same because all the sides match up. 3 goes to 3, 4 goes to 4, 5 goes to 5. These guys have side, side, side similarity. I missed one S. Because their sides are proportional, right? Not the same. Does that make sense? Right? That's the difference there. These are proportional because 3 to 6, 4 to 8, 5 to 10 are all the same. An example of sides that aren't proportional would be something like this. If you had 2 triangles, and we had 3, 4, 5 over here, and we had 6, 8, and 12 here. Right? 3 and 6, 4 and 8 are proportional, but 5 and 12 aren't, so we don't have 3 sides that are proportional. Does that make sense? Right? 2 sides being proportional, 2 S's, not enough to get the job done. These would not be similar. Not similar. Cool. The last one we have is side, angle, side. And again, when we talk about sides with similarity, we don't mean proportional. We don't mean congruent, we mean proportional. So if I had 2 triangles, where 2 of the sides are proportional, that wouldn't be enough to prove it, right? Double S is enough here. But if I knew that the angle between those 2 sides, again, it has to be between, right? Then I would know that they're similar. By side, angle, side, proportionality, right? Similarity. Are we cool with that idea? Okay. And I think still is a really good place to be. Okay. All right, so what we're going to do is we're going to prove sides are proportional. We're going to prove something like this with all the sides, right? And then we're going to rearrange this to get multiplication. That's all. So, let's start. Here's what we have. Alarm bell should have been going off with this. Landry, what do you see? Isosceles triangle. So by isosceles triangle theorem, the opposite angles are congruent. So this triangle right here has this side congruent to this side. So their opposite angles will be congruent. This angle and that angle. Notice it's not this guy way over here, right? We're talking about this isosceles triangle. So the opposite angles in that triangle will be congruent. Okay? So not this over here. Does everybody see that? Right? Opposite angles will be congruent for isosceles triangle theorem. So by isosceles triangle theorem, make sure you get Landry and this with the mask on. Oh no.
I took it off.
Darn.
That was the whole point.
Don't take this the wrong way.
No, just zoom in on
But
my
the shirt you're wearing, Landry, would be something Dolores Umbridge would wear.
Is that
And that's okay.
thing?
And that's okay. My
Is
Harry
it-
Potter nerds, yeah.
Is it really?
Yeah.
I think you should
That's
be-
okay. You're not Dolores Umbridge.
Mac, you're so rude.
So, everybody cool with that? By isosceles triangle theorem, angle A, I'll just call it that because there's only one angle A. Can I call this angle B?
No.
No, I have 2 angle B's, one there and one there, right? So we'll call it by its proper name. How about CBA? You could have also called it ABC.
Easiest.
So we've got that. Great, great, great. Okay, what triangles do A even want to show that are similar, right? Let's talk about that. Well, we want AE and BC involved, so here's AE, here's BC. So we got this whole big side there. That whole big side belongs to one triangle only. The big guy, right? So we want to talk about the big guy being similar to another triangle. AE is here, right? Well, that's part of this triangle, right? AF is part of this big triangle. So it looks like it's going to be this triangle
This
here,
stuff is dumb.
similar to this triangle here. That's what we want to get. So we need either two angles or three sides or side angle sides, something going on here to figure out the triangle is similar. What do you see, Zig?
I was going to try to prove the triangle.
Oh, I don't have a thing here, do I?
Never mind. That's not a triangle.
Call that point G. Sorry.
Okay. What about the point?
Oh, and call that point H. My bad, guys. Yikes. I'm slipping.
I was thinking about proving that triangle congruent, similar to the big triangle, and then doing SAP to get AE.
Which triangles?
Triangles CEH.
CEH? Similar to the big triangle?
Yeah.
All right. Here's how I know that this triangle is not similar to this triangle.
You want to get
Great.
napkin to put
Great.
on. 'Cause you
Here's
don't have-
awesome. Because you take them all and then don't put them back when you're done. All right. This triangle can't be similar to this, or this triangle cannot be similar to this triangle because that's a 90-degree triangle and this one is not, right? Or at least we don't know it is. If we can prove that's a 90-degree angle somehow, we can get it done, right? Could you do that? No. Bummer. So what we're going to do is we're going to focus on these two triangles. The big triangle and then this triangle here. Because those triangles have the parts I'm interested in. AE is this, and that's part of this, right? BC is this, that's part of this big triangle, right? AF, the bottom of this guy, right? And BD, the bottom of this one, right? Oh man, so we got a lot going on here. It's gonna be crazy. Okay, so I'm gonna try the big one and get it to be similar to this guy. Why or why not can I do that? Why can't I prove that this is similar to that? Say,
Same reason as the first one.
exactly right. That's a right angle triangle, and this one, as far as we know, isn't. So yikes. All right, so we're lost. What triangles are we going to prove similar?
That's right.
What triangles can we prove similar?
C,
Say it again.
C, that triangle.
ADC, this triangle right here, and
Again, ACB.
ACB, this big triangle.
Yeah.
Same problem. That's a 90-degree triangle,
I
and
see
this one we
that.
don't know that it is, right? Unless you can prove that that angle's 90, right? Say
You could do ABC and CGH.
ABC and CGH. So this triangle and this triangle could potentially be similar. How would we do that?
Matt, can you toss me a red marker?
And green, right?
Ellen might have something.
What?
Ellison might have
No
something.
marker.
Ellie, what do you think?
There's a
Dominance
marker
was
underneath.
here.
That's okay. Don't be afraid. Guys, shut up.
ADC, BDC.
ADC and BDC. There's a possibility we could prove those similar. How would we do that? Someone help her out, unless you know.
I have no idea.
Okay.
They both at the same angle? And
Yep.
both have a right angle.
Angle, right? We could even do angle, side. Not only can we prove that these triangles are similar, we can do better than that. Can't we prove that they're congruent? Question, are congruent triangles also always similar? Yes. Look at these guys. Congruent triangles, yeah? How does 3 relate to 3? Times what? Times 1. How does 4 relate to 4? 1, 5, 5. 1, right? 5 over 5 reduces 1 over 1, 4 over 4 reduces 1 over 1, 3 over 3 reduces 1 over 1. So they are similar. They all relate that same way. So by proving triangles congruent, we can also say, look, they're also similar. So let's go for it. Let's say that triangle ACB is congruent the triangle BCD. Again, make sure you match up that stuff. And we know that by what? By what? Angle, angle, side, right? Okay, so we have congruent triangles there. Now, we can use CCP now to get a lot more information about these triangles, right? So let's do that. By CCP, corresponding congruent parts, what else can we get on these triangles? Well, we already know that their hypotenuses are the same, right? I think we can also say that this leg must be the same as that leg, right? AD, if you look, AD is first and third here, and this is BD. BD is first and third. So we can say AD, BD. What else can we get? Zayden.
Angles ACD and BCD.
ACD and BCD are the same. And we know that because look, ACD, BCD, first, second, third, first, second, third. So angle ACD compared to angle BCD. So this angle here and that angle there will be the same. Why is this so dark? So we know that those green angles are the same right there. Hopefully you can see the red is green. Cool. So those two angles are congruent. What else can we get? Well, they have that shared side in the middle, right? I'm not going to mark that because that's going to take squiggles, so I'm not going to do that. Although Landry and I talked the other day about how we can mark that this is all congruent to itself. A little squiggle down the middle. Satisfying, isn't it? I like it. So that's congruent to itself. So I guess we could write that. CD, congruent to CD. And we know this to be true by sides, shared side, but instead of writing shared side, I'll just go by CCP, because if you look, CD and CD are in the same spot, right? So that works too. Alright, so we know all of that.
Is this yours? I found this on your desk.
Yeah. If you're a kid today. Oh man. Almost had it.
No, I am. Salem's finest.
That's right. Okay. So we got a lot of information. Great. Now, if those triangles are congruent, then they are also similar. So what parts will they contain? Well, they'll have AC and BC being similar, right? But I'm not interested in AC or BC. I'll also have CD and CD, not a thing I need. AD and BD. Well, I got BD, but no AD, right? So I'm not going to get any information out of that to get this. But I've got more information about a lot of the triangles because of this. So what else can I get? What other triangles can I prove similar or congruent? What other information can I get? Well, we already proved these two right triangles similar, right? Maybe this big right triangle is similar to one of those guys. How do you know? How do you know that this triangle, the one right here, is similar to one of these guys?
Repeat that.
How do you know that this triangle here is similar to one of these guys? Zayden.
Shared side.
They have angle in them.
This triangle here has a right angle and this angle, right? A red angle, right? This triangle also has a right angle and a red angle. So it's going to be similar. Can we prove them congruent? Let's take a look. We've got two angles, and then we have a double blue side and a little bit more. Yeah, probably not. We don't really have anything else, right? So we can't prove them congruent, but we can prove them similar. So I'm going to say that triangle, let's do the one that's sitting down, the bottom one. I'm going to call that AEF. Is similar to triangle, I don't know, which one you want to pick. Let's do the left side right triangle, so ACD. Oh wait, hold on, we gotta make sure we match up our letters. A on this triangle is the same as A on that triangle, right? Okay, so they go together. E on this triangle is the 90 degree. It's gonna be the same as E on as D on this triangle, right? F on this triangle, that angle down there, must go with C on this triangle, right? The last remaining angle, right? So it turns out, well, let's finish this up. So we said we know that by angle squiggle, right? We had two angles that matched. All right, now we can use not CCP, right? But what?
I only do it during practice.
Not CCP, but what? Somebody other than Zadie. If we have the triangle similar, what can we use?
Oh, I forgot what it's called.
What does CCP stand for?
Okay, congruent.
Corresponding congruent parts.
Like,
CSP. Corresponding similar parts. Nice job, Erica.
is that a new one that we did this week?
Yep. So by CSP instead of CCP, we can say that their parts are, their angles are congruent and their parts are proportional, their sides are proportional, right? So let's get some congruent angles. Didn't we already say that C, that angle up here, should go with this angle down here, angle F? And we know that, if you look, C and F go together, right? So I'm going to write angle C congruent to angle F. And I'm going to mark that on my diagram. After I write it, Landry. All right. So we got that. Now, are any of these sides going to be interesting? Well, we want AE, so that's there. We want BC. No BC. We want AF, that's there. And we want BD. No BD. Darn. So we must not have gotten enough yet. Now we chose this triangle and this one to be similar. Couldn't we have also proven that this triangle and this triangle is similar by SS, right? If you look, this triangle here has a right angle and an angle. The same as this triangle has a right angle and an angle, right? So we could also say those are similar. Let's tack that on there. I'm going to scribble this out so I have more room. I'm going to write also similar to triangle what? AEF, ADC, and BDC. This triangle over here. By angle similarity. So all three of those triangles are similar. Now check it out. I want something with AE, and I want something with BC. I want something with AF, and I want something with BD. These two are the triangles I need to get that done. Again, I didn't set out knowing what I was going to do, because unlike congruent triangles, it's really hard to tell which ones are going to go together right from the beginning, right? But if I start working, eventually I can find what I want. And now I know I have what I want because I need AE and BC. Well, these two triangles have it. And I want AF and BD. AF, BD. Okay? So it looks like I've got what I want. So we can say also by CSP, I know that AE relates to what on this triangle? Ellie, take a guess. What would AE relate to on this triangle right here? Look at the letters, not the picture. What would AE go with here?
BD.
Yeah, it's the same as CCP, just, right, it's with similar stuff. Now, we're not going to write that they're congruent, right? Because sides aren't congruent in similar triangles. They're proportional, so we're going to write it like this. Okay? And again, having two things be similar, right? If I give you two numbers, you can figure out how to multiply to get the other one, right? If I say 2 and 4, you double it, right? I say 3 and 9, you triple it. I said 5 and 2. What'd you multiply 5 by to get 2? 2/5, right? The fifth part, the divide by 5 on the bottom, divides the 5 to make 1, and the 2 doubles it. 5 times 2/5. That's divide by 5, so that becomes a 1, times by 2 gives us 2. All fractions are division on the bottom, multiplication on top. That's it. What would you multiply 3 by to get 7? Five times 2/5 gets 2, right? 3 times what gets 7?
Oh.
7/3. Divide by 3 to get 1. It's kind of like cheating, right? Make it 1 and then multiply by whatever you want, right? That's it. That's math. Now, the other way to ask that question is, what do I multiply 3 by to get 7? Well, divide by 3. You get that. Right. I wish you guys had algebra. You know how you learn algebra? There's 4 things. When I have addition, how do I undo it? Subtraction, right? We spend all semester doing this for the 4 operations: addition, subtraction, multiplication, division. In fact, we spend all year doing it. Over multiple years, right? 8th grade and sometimes freshman, or 7th and 8th grade, right? We spend 2 years learning that. That's all it is, guys. That's all it is. That's algebra in a nutshell. And then we learn, oh, okay, we also learn y equals mx plus b, which some of you sort of maybe remember. 2 years or 1 year doing. And that's all algebra is, guys. Yeah. My algebra class is pretty much done already with the entire year. Algebra 2, it's that, but with like squares, so you get like parabolas, not crazy. Algebra 2 is real crap. My kids are doing algebra 2 stuff sort of right now in algebra 1. Because you just run out of stuff to do. Once you understand it, it's like, okay, how many times can I ask? I have a plus 2, how do I get rid of it? Subtract 2, right? I have a times 5, how do I get rid of it? Divide by 5, right? I don't know. It doesn't have to be that hard. All right, so we have this. AE and BD go together. And I'm also interested in BC and AF. So BC and AF, oh, they do go together, first and third, right? So I'm going to write AF on top, because that's for my first triangle, and BC on the bottom, because that's for my second. Is everybody cool with that? All right, now how do I get that to look like multiplication? All right, algebra students. I've got divides by BD, and I want to get rid of it. What do I do?
Multiply.
I multiply by what?
Division.
I multiply by division?
What?
Yikes. It's like I'm in 7th hour. All right.
Dang.
I multiply by BD. To both sides. Whoa. I haven't made this joke in here, I don't think, because it's not my algebra class, but here's what I do. Ellie, you prepared for this? Hold on. Before and after.
Before and after.
All right, here we go.
6 freshman, 5 something.
I think I know what you're gonna do. I think you did this to us last semester.
No.
Oh, yeah.
Beam.
All right.
Yeah.
Yeah, you
If
did
you
this
do it to
to
one
us.
side, it's child abuse, but if you do it to both sides, it's algebra, right?
Yeah, you did that to us.
Exactly, all right.
We did that
After.
too.
Everybody has
Natalie,
it, does.
Natalie and Mark last semester.
No,
I don't know if
you
you guys
should
notice,
just
but whenever a kid like shakes my hand or high fives or whatever,
It's
I
all
do
legal,
hand
it's
signs
the paper.
afterwards. You guys are.
I
I'm not a germaphobe.
Feel pretty germaphobe.
I just know you guys. Oh my god. Kobe. All right. So when we do this, right? Why does BD and BD cancel over here? Why does division and multiplication cancel? Here's why. Here's why. We're doing BD divided by BD. You can do any order you want. You can times first, divide first, whatever you want. Instead of dividing AE by BD, which is some, I don't know what that is, I'm going to divide BD by BD. What's any number divided by itself? 1. So now we have 1 times AE. What's 1 times AE? AE. 1 times anything is itself. So that's why they cancel. Really what happens is they become 1, and 1 times anything is itself, right? And that's why we did it. Now over here, nothing cancels because BD divided by BC is some number. I don't know what that is. So I have to write it like this. Remember, division is done on the bottom, multiplication is done on top. So if I want to multiply, where's BD going to go? On top. Times BD. Aw, man, I don't want divides by BC, so what am I going to do to get rid of that?
Multiply.
To both sides. And what am I going to multiply by? BC, right?
To 4.
Now, why does that make divides by BC go away? Because we're doing BC divided by BC, which is 1. So that's 1. Now we have 1 times whatever's left over. Well, it's going to be whatever's left over, right? 1 times anything. So now we have to do it to both sides, otherwise it's child abuse, right? That will hold up in court.
No, just do it to pay.
And now we have this. Right? Because this cancels. Cancel culture. We gotta edit it right now.
Cancel what?
Cancel, right? Why does it cancel? Well, because it's BC divided by BC. Why does plus 2 and minus 2 cancel? Because positive 2 and negative 2 minus 2 it's 0. It's 0.
No.
So sometimes when we cancel, it's 0, and sometimes when we cancel, it's 1, which is why we shouldn't use the word cancel. Cancel culture right now, yes?
Do we have a test tomorrow?
No.
We don't like that.
We do next Thursday. Maybe it will be a test.
Yeah.
No.
Nah. I've kind of decided no tests until the final.
Yeah.
That's kind of what I've decided. I'm not sure if it's like 100% for sure, but I'm pretty sure.
You're up
All right.
to the test?
So, did we get what we wanted?
Looks fine. It's just
Yes or no?
so different.
Do we have what we wanted?
Yep.
We have something close to it, but how can I make it actually the right thing? They have AE times BC, I have BC times AE. Am I allowed to just switch those? Why? Give me an example of why that works. You don't have to give me a property. Explain why I'm allowed to switch those two
Because
things.
if you do 2 times 3, and then you do 3 times 2, it's the same thing.
It's the same thing, right? Commutative property.
Big break.
Forward and backwards, same thing. So we can just write it like this. Medium brain. And now we're done. Ellie, how do you feel?
Not as bad as I thought I would, but not good.
Okay, so we're going to go back up and go over it again. And then we're going to do number 4. I gave number 4 to the first hour yesterday as like just the first thing we, like the third thing we did, and it was, there were casualties. It was bad. So I've decided to like make more, and then we're going to go back to 4. Okay, so check it out. Ellie, Isosceles Triangle theorem, 2 sides are the same, so opposite angles are the same. Then we said because we had 2 angles in this triangle that matched 2 angles in this triangle, right? We said that they were, no. We said congruency. So we said this triangle and this triangle are congruent because they have side angle angle, or angle side, right? And if they're congruent, we got this, all this information. We found out that AD and BD were the same thing, so these bits were the same. We found out that ACD and BCD were the same angle. We found out that CD is the same to itself. All true stuff. Is it useful? I don't know. Sometimes that'll happen in proofs, right? There's lots of true things you can say. Might not be helpful. For instance, aren't those vertical angles? Did we need it? No. It happens. That's okay. AEF and AEC, we proved that were similar because it looked like if they're congruent, then they got to be similar, right? And we know that because we have shared angles, right? Okay. And then we also found out that this guy is also the same as them because it has the same angles. So we got all that. What was useful is these two being similar because that's the stuff we needed, right? So then I said by CSP I get those angles, blah, 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 but I also get, more importantly, these sides. Not that they're congruent, but that they're proportional. They relate the same way. I moved stuff around and I got multiplication. Okay. Angles will be the same for similar triangles. Okay. Sides will be proportional. The way we write that is like this. Okay. This tells you which ones go together and that they relate the same way as another one. Okay. So if one was 1 and that's 2, right? If this was 3, that would be 6. Do we know how they relate? Is it double, triple, quadruple, half? I don't know, but I know they do. Okay. Here we go. It's time, boys. We're on to number 4. Bum, bum, bum.
We already did this.
Did we do 4?
Yeah.
Did we not do 5?
We did not finish 4.
Yeah, we didn't finish it.
Okay, but we're going to go back through it. Ellie, okay?
I don't want to see it.
Yeah, where's the class?
I only have
All right, for those of you that already have written down, don't write anything down, which is what you should probably be doing anyway, but like, okay. Okay. All right. D is the midpoint of AC, so that means it cuts this into 2 even pieces.
Fun.
E is the midpoint of BC. Now, Ellie, I do not know that these two are the same. So when they're cut into halves, this half is going to be different than that half. Could be, right? Rad. So we do not have an isosceles triangle here. Do we see that? Do we see this is not isosceles? It could end up being that the blues and the reds are the same. Maybe we figure that out later, right? And have to go back and change things. But right now, we're just talking about a generic triangle, right? We do know that D and E are the midpoints. So what we're going to prove is that some sides are proportional. And we actually are going to prove that they're proportional by a certain number, double. Okay? So what we're going to prove is that BF and DF relate. So check out, BF is this right here, and DF is this right here. So what we're saying is that BF is twice as big as DF. That's kind of rad. All we've done is take a random triangle and connect the vertex to a midpoint, vertex to a midpoint. When they intersect, we'll always cut up into double here, half there. So if this was 4, this would be 2. If this was 12, that would be 6. This is true for any triangle. These segments right here are referred to as medians because they go from vertex to a midpoint, median meaning middle, right? And when the medians intersect, and they always will, the point that they create is called a centroid. It's actually the center of mass for a triangle. So if you want to balance it, that's where you put your finger, right there. And it cuts up into 2/3 versus 1/3, or 2 versus 1, right? That's what we're going to prove. It's true for any triangle. I could have drawn the other median in, but it would just clutter things up, right? They're always going to intersect at one point. We can actually prove that as well. But we won't. We're going to prove this. So, somebody, tell me what else I can add to this diagram. You can cheat from yesterday. What can I do?
Shared angle.
Shared angle. So guess what? What we're trying to prove is that BF
No clue I knew.
and DF are the same,
Lucky guess.
right? So we're going to prove first off that this triangle here is similar to this triangle here. Why? Because it's easy pagans, right? So notice that the top triangle shares that top angle with the bottom triangle. They literally share it, right? So we have shared angle. We never had shared angle before, right? But now we do. It's something that we're going to see. So this angle at the top, by shared angle, similar to shared side, right? Angle C is congruent to angle C. Rad. Now remember what we can do to prove similarity. We have SAS similarity, we have SSS similarity, and then we have the one that we love to use because it's so easy, double angle, right? What do we have here between the top triangle and the big triangle? What do we have? We have side angle side. We have proportional sides, right? And we have a shared angle, right? A congruent angle. You see how the sides are proportional? It's 1 versus 2. 1 versus 2. Right? And again, we're comparing this triangle to the top triangle. So it wouldn't be this to this. It'd be this to that, right? You smell what's happening there?
Kind of.
Cool. Well, it would help if you weren't on your phone all the time.
I know.
By side angle side, similarity. Just a heads up, none of you, not a single one of you, not a single one of you is smart enough to be on your phone and totally get this and pass the quiz. Not a single one. You thought the last quiz was hard? You thought the last quiz? You
The
have
last
no
quiz was
freaking.
easy.
You have no freaking clue. Okay. This next quiz, oh my god.
I don't.
Okay.
It doesn't matter. I'm gonna fail you.
No.
Yeah.
Okay. So I appreciate if you weren't on your phone because I know we're gonna have to damage control, right? You know what hubris means? It means overconfidence in yourself, and you deserve to be punished for it, right?
Yeah.
Right. That's what's happening when you get that bad grade. You got it because of hubris.
I used
Right?
treated
Okay. Side angle side. We know that the two triangles are similar. Which triangles? I'm going to start with the top triangle and call it CDE just to keep it alphabetical. Is similar to the big triangle. The big triangle, I need to match up. Notice that they both share angle C, so they're going to go together. D, this angle here, is made up of the blue side and the unknown side, right? So if I look to the proportional blue side and the unknown side, it's going to go with A, right?
Was it pretty good yesterday?
E is made of the red side and the unknown side. Proportional red side and unknown side will be angle B. Okay? So those go together. Now that we've proven that, what we're going to do
CCP.
is we're going to use CSP, because we can't use CCP, it's similar, right? To prove other things about those triangles, right? We're going to get as much information out of this as possible. Once they're similar, you can unlock a lot, right? Namely, we're going to unlock some angles. Again, lots of things is fine. I'm trying to streamline it right now so you can see the pattern. Once you get it, you'll know what's useful and what isn't, right? So, what we're going to say is by CSP, angle D, this angle here, is going to go with angle A. Now, we can't call it angle A because there's two angle A's here, right? We can't do that. So we have to call it by its proper name. This angle right here is angle CDE. CDE. We did that, right? And if you look, CDE is first, second, third, right? So it should be congruent to CAB, first, second, third. CAB. Ah, it is. Now, could I do that to the other side? Oh, yeah. But I'm not going to do that yet. Okay? Am I? Now. Alright. Everybody cool with that? Now. You guys remember, if we have two parallel lines, and they're cut by another line, that line is called what?
Transversal.
Very good. And again, even if they're not parallel, we call it transversal. However, when the lines are parallel, something magical happens, right? What happens? Corresponding angles are congruent, right? So these two angles are corresponding. If the lines are parallel, then they are the same angles, right? Turns out cap has a converse, and the converse is true. Not every theorem has a converse that works, right? Not everything goes both ways, right? But this does. So before we said, if the lines are parallel, then the corresponding angles are congruent. Now I'm saying, if the corresponding angles are congruent, then what do we know about the lines? What do we know about these two lines then? They're parallel, right? So cap is true forward and backwards. So this is cap converse, right? We're going the other way. So we're going to say by cap converse, we know that DE is going to be parallel to AB. Do you see it? Now that they're parallel, we can do all kinds of crazy stuff. Check this out. What I could do, and you're not going to do this, is I could say that this angle right here is the same as this angle down here, right? You see it? By cap. And then I do vertical angles and I get this guy, right? I'm going to cut to the chase. Remember alternate interior angles? Alternate interior means that alternate opposite sides of the transversal, right? In the interior between the parallels. Here's the parallels, that's the interior, right? This is opposite side. So alternate interior angles just is a shortcut, cap to vertical, right? That's all it is. It's just a shortcut. So I'm going to say by alternate interior angles, theorem. Alternate interior angles theorem. I know that angle EDF is congruent to angle FBA. All right. And I bet you guys saw earlier, don't we have vertical angles here and here? So I'm going to write that. Why did I do that? How did I know that would be helpful? Well, I'm going to try and prove these two triangles similar. Because if they're similar, that guy and that guy will be matched up. And that guy and that guy will be matched up, and that's what we want. You guys see that? BF and DF together, right? So these two triangles, and AF and EF together, these two triangles again. So if I get these two triangles, I win, right? How do I know that those two triangles are similar? Somebody other than Zayden? I appreciate it, Zayden. Don't stop raising your hand. I want to give people time to catch up. How do I know these two triangles are similar? This one and this one. Look at the diagram. How do I know those two are similar? Don't be afraid to guess. Angle, angle, right? We have two angles that match. You see it? So this triangle and this triangle are similar. By angle, angle similarity, angle, angle squiggle, we know that triangle, I'm going to do the top one first, so that's angle, triangle DEF if I do alphabetical order, similar to triangle. All right, now we got to match them up. Angle D is going to match up with what angle on the bottom triangle? B, right? Angle E must go with angle A, and angle F goes with itself. If the triangles are similar, aren't their parts proportional? Right? Sure, we could get the other angles, right? We could say, look, that angle right here is the same as this angle down here. Great, so whatever that is, it's going to be this. But we don't care. We want sides, right? So let's talk about their sides by CSP. By CSP. Let's list all of them. We don't need all of them, but we're going to list all of them. DE is going to be proportional to what? Look at the letters. BA. That's what you want. EF goes with what? AF. BAAF. Nice. All right. And what about DF? I like the bottom here. This is like amazing. BAAF.
Darn it.
Do this for homework. Do the last bit of the proof on your own.
Definitely.
For sure. I will.
You can do it, right?
No.
Yes, you can. Look. We're so close.
Here's the thing.
You're really not that close.
You actually are. And the bottom says B-A-A-F-B-O. I feel like that's like a
He's looking
sentence.
for the folder.
Huh? Mr. Matt, I got lost in the folder and I think some people in this class.
Hey, it's over here.
Okay.
That's all it says.
Ooh, I forgot something.
Oh, I see it.
During homework. There you go.
Number 4, are we allowed to do the meridian thing to prove that they're double and half?
These two things?
Yes. That.
No, because that's what we're trying to prove. So we can't say by median theorem, those two are the same, right? What we're doing is we're proving that right now. So what you would do from here is you'd say, look, I know D and BA are going to relate the same way as this and this do. Because these two triangles each other. That's what we're going to do next.
Yo, bro, my parents are
And so, because this is the one
Let
and
them
two,
get sick.
this will end up being.
Close, or not bring them to school. So I'll just
So
put
which
you
two
on
triangles
to
is this
it.
one? This one?
Yeah,
that
this
sounds
one and the
good
big
to
one,
me.
we're going to show that, right? And then because
did
those
get
two are
it.
similar,
Can I use the rest
we're
of
going to say that this side must be half of, like, right? And now I've got this for that and this for that, right? Cool.
Mr. Mack, you got it?
Yeah. Where was it? What is it?
No, I chucked it under the door.
Oh, that was you. Okay. Yes. Huh. Okay.
Does anyone else miss Alessio? Like, do any of you guys know Alessio?
Who's the lucky?
Car?
The foreign exchange student from last year.
I don't know.
The Italian.
Like international pop star Alessia Cara.
I literally miss him so much. His time was funny.
Oh, it's a guy. Okay.
Oh yeah, he's a guy.
Hey, yo, boys, I got the Thin Mint cookies.
Nice. Thin Mint is dope. Also, Girl Scouts are great. Very pro Girl Scout.
Okay, one time at the Boy Scouts or whatever.